Okay, the next phase of this unit of work is where we still have the similar type of thing, but instead of being bounded by the x-axis, we have a situation where we're bounded by the y-axis. All right, so all this means is instead of going up or down this way to bound our curve, instead we are really going this way, all right, and getting our area regions to be bounded by the y-axis. Now the only difference it's going to make with how we go on about doing our questions, it's going to be the same types of ideas, is that when we do our integration, we're going to have to integrate the function in terms of y with respect to y instead of x. Alright, so similar type thing. Now, same as before, we can have negative areas. So everything on the right-hand side of the y-axis is going to be positive. Anything sitting on the left-hand side are going to give you negative values. Alright, so this top one up here is a positive, and down here, if we were to be bounded by the axes, this would give us a negative value. The only other difference is our expression is going to be given to us as x equals f of y. Okay, in example number 6, it says find the area enclosed by the curve x equals y squared, the y-axis, and the lines y equals 1 and y equals 3. Okay, so let's start with a quick sketch. Okay, so this one is x equals y squared, or our sideways parabola type idea. And we're asking to find between this point here of 1 and this point here of 3. Okay, the good thing about this question is because it's all to the right hand side of the y-axis, it's going to be all positive, and we're going to be integrating y squared dy. Exact same integration type rules apply, except we're just doing it in terms of y. Okay, so we're still going to raise it to a power and divide by the new power, and we're still going to go and substitute those 2 points, just like so. And plug it into our calculator and get ourselves 8 2/3 square units. Example number 7 states, find the area enclosed by the curve y equals x squared, so regular and parabola, but it says the y-axis and the lines y equals 0 and y equals 4. All right, let's sketch. Okay, we have our parabola, y equals x squared. Now we're asked to examine the area enclosed by that curve, the y-axis, and the lines y equals 0 and y equals 4. Alright, so all of this area in here is what we're trying to find. Now, who could tell me something about this one? Yeah, that's right. We're going to have a negative area and a positive area that hold the same value. So yeah, we're going to find the area between 0 and 4 just for this side, in that first quadrant, and then we're going to double our answer. Okay, so we're going to go between 4 and 0 of that f of y. Now this is where we've got to stop and think for a little bit, because our original expression is not given to us in terms of y, it's given to us in terms of that x. So we're going to change this. So if we get y equals x squared, that means x equals the square root of y. Now it's really plus or minus, but because we're considering that first quadrant where this is going to give us a positive value, we're just going for square root y. Now if we're going to be integrating or doing anything with calculus, we know we're going to have to change that to a fractional indice. Alright, so there's our function, x equals y to the power of a half. So that's what we're going to use. But also let's remember we're doing 2 lots of it, okay? Between 4 and 0. Integration of this stays the same. Okay, so y, add 1 to the power, 3 on 2, divided by 3 on 2. Okay, before we go and do our substitution, I think it's probably a good idea to just go and tidy this up a little bit. So remember, dividing by a fraction, we flip reciprocal and multiply. So it's 2y cubed, all square rooted, over 3. That's what we'll substitute 4 and 0 into. Okay, so there's our substitutions, the 4 and the 0. Sorry to go sideways, but we plug that in our calculator, and it's going to give us an area of 10 and 2/3 units squared. Okay, example number 8. It says find the area enclosed by the curve y equals the square root of x plus 1, and the y-axis and the lines y equals 0 and y equals 3. Alright, let's sketch. Okay, so if we were to graph this one, think about just y equals square root of x. Okay, so it's going to have those values of 1 and 1, 4 for x, 2 for y, etc. But it's plus 1, so it's going to be shifted back. Everything's going to go back to the left 1 space. So this value here of 1, 1 would then become 0, 1. This value here of 4, 2 would become 3, 2, and so forth. Alright, so let's get rid of this curve and now draw a real one in. Everything shifted back 1 unit. Same general shape. Okay, this is a value of 1. This is 3, 2. And this is -1, 0. Okay, so there's our curve sketched. This is now the problem we're going to have to deal with. We're after the area enclosed by the y-axis and value 3 for y and 0. So these are the areas we're going to have to find. You'll note that this bottom little area down here is going to be negative, while this big area here to the right of the y-axis is going to be positive. But before we begin any integrating, we're going to have to change the subject of this curve, so x is the subject. So squaring both sides, we get y squared is equal to x plus 1, which means y squared minus 1 will equal x. So this is now the function we're going to have to integrate. Okay, so the area is going to be this top one, the positive one, which is going to be from 3 to 1 of y squared minus 1, plus the absolute value of the area between 1 and 0 of y squared minus 1. Alright, so two distinct areas there, the second one being negative, so we've got to make sure we're using our absolute value. Okay, so now to just go and integrate, we get y to the power of 3 on 3 minus y between 3 and 1, plus the absolute value of y to the power of 3 on 3 minus y between 1 and 0. Okay, now it's time for substitution. Okay, so there we go, our substituting right the way through. Now going and putting them into our calculators. With something like this one, I'd definitely do them separate. So this first one is 6 and 2/3. And the second one gives us an absolute value of just 2/3. So we've got 7 and 1/3 units squared being our final area. I just think doing these separate parts as individuals is a bit better, because if you make one mistake, it's easier to narrow it down to where you've made that substitution error. Alright, now you have enough bit of knowledge under your belt to go and try exercise 3.7, the questions we've given from you from that for homework, before I go and address the last part, which is the area between two curves.